Welcome back to this channel. Okay, before we start, just share with you the final answer for the tutorial question 4B and 4C at where we already discussed in the previous video. So the arrangement for the ion is N plus is the smallest, and then the size will be increasing up to M2 negative because they are isoelectronic species. So that's why when you discuss, we have to discuss the factor of effective nuclear charge. Okay, for question 4C, the element of N atom has greater radius than the ions N plus. Since both of these, when you write the electron configuration, they are showing that they have a different number of shells occupied by electron. So that's why shielding effect is used. Okay, now let's look at the learning objective in this video. First, we need to know the definition for the first ionization energy and also the second ionization energy, where we always will use IE to represent the meaning of ionization energy. Then as usual, we are going to analyze the variation of the ionization energy across the period and also down the group. Okay, so we already have the idea if about the radius across the period, the size is getting smaller, while going down the group, the radius is growing to become bigger. Okay, so now we want to know how about if across period, what will happen to IE, and going down the group, what will happen to the ionization energy as well. Then next we have to one more term again, which is the successive ionization energy. So we need to understand this term, and then it can help us to deduce the electronic configuration, and then next can be determine the position in periodic table. So this position mainly is always focused to the group number. Let's continue with another character of the element in the periodic table, which is ionization energy. What is meant by ionization energy? Minimum energy required to remove one mole of outermost electrons from a gaseous atom. After this, we may use IE to represent ionization energy. Okay, this is a very general definition for the ionization energy. Sometimes it can be asked you to state the first ionization energy and also second ionization energy. So just want to keep in mind that the difference between first ionization energy and second ionization energy means that first ionization energy is the energy required to remove the first electron from an atom. However, second ionization energy is the energy required to remove the second electron. Do keep in mind that the electron is removed one by one. So when we remove every electron, there is certain energy is needed. So now, let's look at what are the difference in the definition when we write down this first IE and also second IE. The minimum energy required to remove one mole of electron from one mole of gaseous atom. The first electron removed always are from the atom, and then it will become a uni-positive gaseous ion. Uni here means a positive one. Okay, so from here we can come out delta H equal to positive value kilojoule per mole, means that energy is required. Okay, when we look at the second definition for the second ionization energy, we will notice we still say that minimum energy required to remove one mole of electron. But this time the electron is not from gaseous atom, but is from the uni-positive gaseous ion, because this is the second energy that removed from the atom. So means that M2 plus now will become the reactant, and it will produce M2 plus. Now proceed to the tutorial question number 5a. Define the term first ionization energy. So just now we already introduced three definitions. So first is ionization energy. In this case, it is not suitable. Okay, then we have first ionization energy and second ionization energy. So definitely this is the definition that required. Let's say you think that the sentences that you make maybe is not correct, then you can support it by the chemical equation. Okay, but you cannot just write the equation without the definition in wording. Okay, let's look at the variation of the ionization energy across the period and also going down the group. So based on the sign given here, across the period, the IE is increasing, while going down the group, the IE is decreasing. Let's look at the explanation. Across the period, as we already know, proton number will increase and cause the effective nuclear charge increase. Once the effective nuclear charge increase, attraction between nucleus and also valence electron increase. This makes the electron is more tightly held to by the nucleus. So, and then with this case, next we relate with the definition of ionization energy, which means more energy is required to remove the valence electron, and hence the ionization energy is increasing when going down the group. So from here, we can make a quick summary. If effective nuclear charge increase, the size will getting smaller. At the same time, the IE will increase as well. Okay, next goes to the down a group. When going down the group, number of shells occupied by electron is getting more and more. This causes the shielding effect increase, and hence the force of attraction between nucleus and valence electron become weaker, which means less attraction between nucleus and electrons, so less energy is required to remove the electron. And the IE will going down or decreasing going down the group. Okay, generally we already have the idea where across the period the IE supposedly is increasing. However, when we look at the graph showing here for the element in period 2 and period 3, yes, the graph is increasing, but they are not increased in the straight line. There is anomalous case in between beryllium and boron and also nitrogen with oxygen. Same case happened in the element in period 3. Also have an anomalous case between magnesium, aluminium, phosphorus and also sulfur. Okay, so at where we notice beryllium, ionization energy of beryllium is larger than boron and nitrogen larger than oxygen in period 2, and the same case happened to the element in period 3 as well. So these cases we consider they are as anomalous case, which is abnormal and means different from expectation. Okay, we expect beryllium will have lower IE than boron, but here they show that beryllium have larger IE than boron. Okay, so to always, and then at the same time, we also notice beryllium is element in group 2, magnesium also element in group 2, nitrogen element in group 15, phosphorus also element in group 15. So means that if you go to the period 4, period 5 and so on, the anomalous case will happen in between this group. So after we notice the anomalous case, then we need to do some explanation. So now here we only focus on period 2 because the trend for period 2 and period 3 are similar. Okay. Then we can focus on the electron configuration. So for beryllium, the valence electron configuration is 2s, while for the boron is 2s2, 2p1. Okay, just a remark here, we will prefer to draw 2p orbital instead of 1. Okay, so when we look at this one here, what is the explanation that given? Is like this. We will say that 2p orbital of boron is further compared to the 2s orbital. So that's why less energy is required to remove the outermost electron of boron. Next, for the nitrogen, we need see this. There is three 2p orbital, each of them filled with one electron. This case we call the orbital is half-filled orbital. While for the oxygen, the electron configuration is filled into the 2p has 4 electrons. This situation we know the orbital as partially filled orbital. So if we recall back to chapter 2, half-filled and partially filled orbital, we know there is a special condition, means that there will be have extra stability for the half-filled 2p orbital. So that's why we need more energy to remove the first electron instead of the partially filled orbital. Okay, now let's continue with the tutorial question. Question number 6. We have to explain the statement. Okay, so when we look at here, they are asking us about the ionization energy. Why the first ionization energy of aluminium is less than magnesium. Okay, so both aluminium and magnesium are elements in the period 3. Okay, question B asks us about the second ionization energy for the sodium in second ionization of sodium and also magnesium. So before we can answer this question, so we have to know what are the factors that we can explain. Okay, so means that by understanding the ionization energy, we know that we need to know the electron is removed from which orbital. Then also need to keep in mind that there is anomalous case happen in the ionization energy when we discuss about ionization energy. Okay, so that is why it will be always encourage you to write down the electron configuration. Okay, so for the anomalous case, basically we will focus on the extra stability, which only always happen for the p and d orbital only. Okay, so I believe you all already know half-filled and full-filled orbital have the extra stability. Okay. Okay, now let's continue to answer the question. So before we can give the explanation, then it will always suggest you to write down the electron configuration for aluminium and magnesium so that you will know the electron is removed from which orbital. Okay, aluminium have 13 electrons, so will be 1s2 up to 3p1. While for the magnesium have 12 electrons, so we'll have 1s2 up to 3s2. Okay, so based on the electron configuration, we will have the idea that first electron removed from aluminium is from 3p, while the first electron removed from magnesium is from 3s orbital. So, and then when we look at this case, it is in between group 13 and also group 2. So this is the anomalous case. So, and then we know for this category, we are going to discuss about the distance. Okay, so this is the explanation that you may write it down. The 3p electron is further from the nucleus compared to 3s. Therefore, more energy required to remove the electron from 3s because it is more attracted to an electron in the 3p orbital. So that's why aluminium has less IE less first ionization energy compared to magnesium. Proceed to question 6b. The second ionization energy of sodium is higher than magnesium. So, as usual, always need to write down the electron configuration. So just now we already write for magnesium. So it's 1s2 up to 3s2. Okay, then next we have sodium. Sodium have 11 protons. So 1s2, 2s2, 2p6, 3s1. This is the electron configuration for magnesium and sodium respectively. So in this question, we want to check out the second ionization energy. So for the magnesium, the second electron will still remove from 3s orbital, while the second electron that removed from the sodium will be from 2p orbital. Okay. Then now, what's the difference between 2p and 3s orbital? So 2p, if you look at here, is after we remove one electron, the electron configuration will become 2p6. Okay, so now means that we want to remove the electron from 2p6. So based on this 2p6, we will have the idea that the orbital is completely filled or or full filled. Okay. So when you do the explanation, again, we will mention sodium has higher second IE because the second electron of sodium is removed from the completely filled 2p orbital. So what happened if it is completely filled 2p orbital? Because uh, it has extra stability. So that's why the ionization energy, second IE for the Na is higher than the magnesium. Okay, now let's continue with the successive ionization energy. So what does it mean? The energy involved in removal an electron successively from an atom or ion will be known as successive ionization energy. So as we know just now, when we want to remove we want to remove electron, energy is needed. So now let's say we try to remove 5 electrons from the same element. So generally the energy required to remove first electron and second electron will be different, at where second IE will be higher than first IE. And third IE will have higher than second IE, fourth IE higher than third IE, and so to the fifth fifth IE that will be higher than the fourth IE as well. So now, let's look at the explanation. When each electron is mover and then is success, the atom or the element will become more and more positive, increasingly positive. Let's say, at first we remove one electron from M. So after remove one electron, M will become M plus. Second electron, M will become M2 plus. Third electron, M will become M3 plus, M4 plus, and M5 plus, and so on. Okay, so means that the positive is increasingly. Therefore, the remaining electron will be more attracted or strongly attracted to the nucleus. When it is strongly or more attracted to the nucleus, more energy is required to remove the electron. Okay, so do keep in mind that the more electron that you remove, the IE will become increasing. Okay, let's check out how the question related with successive ionization energy will be asked. So now look at the structure of the atom. The first electron that we are going to remove is from the outermost shell. Okay. Second electron still from the outermost shell. Third electron still from the outermost shell. And then fourth electron is from inner shell. Fifth electron also from the inner shell. So now let's look at the IE value. So first electron removed, we need 100. Second electron need 200 kilojoule per mole. Third electron 400. Fourth electron 4000 kilojoule per mole, and the fifth electron 5000. So when we look at this value here, it is similar with what we expected follow the previous slide, which means that the ionization energy will be increasingly higher and higher when the more electrons that are removed out. Okay, then now how we are going to use this information to determine the group or the block of the element. Okay, so as here mentioned, IE1 smaller than IE2, IE2 smaller than IE3. Then IE4 suddenly larger than IE3. So here we have the term drastic change, at where it also sometimes can be known as sudden increase, or there is a big jump. Okay, so then now we look at the structure of the atom. The fourth electron is in the inner shell. Okay, so means that this suddenly increased IE value is due to the inner electron is closer to the nucleus. So that's why the attraction is stronger, and then much more energy is required. Okay, so later when you answer the question, basically we are going to find the ratio and then try to calculate which part of the ratio showing the largest. Okay, so a drastic increase in successive IE occur, which means the electron removed is from the inner shell. So in this case, the sudden increase happened at the fourth IE. So means that the fourth electron is from the inner shell. So if the fourth electron is from the inner shell, means that there are 3 valence electrons, and indirectly, if there is 3 electron, means that we already know there is group 14, group 13. So if there is group 13, means that it is p block element. Now let's continue with tutorial question number 6b. The graph below shows the variation of ionization energy for all electrons for atom P. Okay, so here one dot here means 1 electron. Okay, so now we have electron A and also electron B. So which electron is from the outermost shell? Yes, very good. Electron A is from the outermost shell, while the electron B is the innerst one, innerst electron. Okay, so now I will get the idea. In the first shell, we have 2 electrons because we have 2 dots. When there is a sudden increase, means that the electron is from the outer shell. So here we have 1, 2, 3, 4, 5, 6, 7, 8. So means that second shell have 8 electrons. And then third shell we have 1, 2, 3, 4, 5. 5 electrons in the third shell. So write the electronic configuration for atom P. So in this case, you are going to write the SPDF notation because of the keyword here, write. Please don't give the orbital diagram. So 1s2, 2s2, 2p6, 3s2, and 3p3. Okay, so this is the answer for atom electronic configuration for atom P. Next part of the question, state the most stable oxidation number for atom P. So 3p3 means that the electron need to gain 3 electrons to achieve stable octet electron arrangement. Okay, so when we mention stable octet electron arrangement, so, but the question here is asking about oxidation number. So the final answer for the oxidation number is -3. Okay, so sometimes please alert with the question whether the question is asked us to give the oxidation number -3, charge of the ion +3, formula of the ion P3 negative. Okay, it looks like quite similar, but actually what they ask us to write is different. Let's continue with the question part 3. we're still referring to the same graph. And then for part 3, they ask us to determine the group of the element P in the periodic table, and then we need to do explanation. So again, before we start to answer this question, you have to know that the first electron removed always is from the outermost shell. So this is the first electron to be removed. And this electron is from the outermost shell. Okay. Then, if there is a sudden increase, means that the electron is from the inner shell. So we can spot that the sudden increase is in this part. So first electron removed, second electron, third electron, fourth electron, fifth electron, and this is the sixth electron. So it means that this sixth electron is from the inner shell. So now we need to do the explanation before we can know the group. Okay, this is the way we do the explanation. There is sudden increase between IE5 and IE6, which means the sixth electron is from the inner shell. And then at the same time means there are 5 valence electrons. So if there are 5 valence electrons, means that the element P is from group 15. Last part of question number 5b, we still based on this graph. Explain why the successive IE increase. Okay, so the keyword here is increase. And then this one, just now we already identified. This is the first electron going to be removed. Okay, so means that the more the electron that you remove, the greater the ionization energy. So now they want us to explain why. Okay, so this is the most simple answer. The attraction between the nucleus and the remaining electron. Okay, nucleus and the remaining electron become stronger. So once the attraction stronger, means that harder to remove electron. So if harder to remove electron, means that we need more energy to remove the electron, and at the same time means that the ionization energy will be increased. Question related with the successive ionization energy can be given in graph like just now, question number 5, or like tutorial question number 7, give us a set of data where there is 4 elements U, V, W, and X. So let's look at what is the question asked about. First part, A1, identify 2 elements which are in the same group, and then state the group number and also explain. So to answer this means that we have to find out the sudden jump or drastic increase between 2 ionization energy. So let's us identify together. So the sudden increase happened between IE2 and IE3 for the element U, while for the element V is in between IE3 and IE4, while W is in between IE1 and IE2, and then the last one, element X, the sudden increase is in between IE3 and IE4. So now, from here, we can see there is 2 elements have changes at the same pattern, which is in group 3, in IE3, between IE3, from IE3 to IE4, element V, and then X also same, there is a sudden increase from IE3 to IE4. Okay, so this is our answer. V and X are in the same group. So because there is the 4th electron, from here we get the idea, 4th electron is from inner shell. So means that there are 3 valence electrons. So it is group 13. Okay, V and X same group. Both of them are in group 13. So now we need to do the explanation. because there is sudden increase in between IE3 to IE4, which means more energy required to remove the fourth electron. Why more energy? Because the fourth electron is from inner shell, which show that they are closer to the nucleus and hence they are strongly attracted to the nucleus. So in other words, to say we need more energy to remove the fourth electron. So end up with this, both of the element V and X consist 3 valence electron. So both of them are in group 13. Let's continue with the next part of the question. Before we continue, recall back again. This is the sudden increase that we identify between second IE and third IE, and then third and fourth, and then first and second. The next one is the third and fourth also. Okay, then now let's check what is the following question. Explain the differences for the first ionization energy for the two elements above. So these two elements is referred to U and V. Yeah? Okay, so because they are in the same group, so we will have idea they will be in the different period. Okay. Next, based on the value here, we will notice that we have smaller value or smaller first IE compared to X. So because of both of them are until with the two different energy or two different period, so they will have two possibility is Vx or Xv. Okay, so from here we get the idea. We have to think about when going down the group, what happened to the IE? So in general, we know that IE is going to decreasing. So in this case, we are going to know V is smaller. So V is 550 kilojoule while X is 800 kilojoule. Okay, so let's continue with the explanation. So why V? Because we have greater shielding effect. Okay, because they are at the bottom of the periodic table. If the V has the greater shielding effect, this means V has larger atomic size. When V have the larger atomic size, so the attraction between the nucleus and the valence electron will become weaker. Once the attraction weaker means that we need less energy required to remove the electron from the outermost shell, okay, or outermost electron from V. So that's why they have different first ionization energy even though they are in the same group. Okay, next question is asked about which of the element can form ion with the charge 2 positive. So if an element can form 2 positive, for example, we remember magnesium, okay, and then can become magnesium 2 plus. So means that we will have the idea if the element with the charge 2 positive means that it will be from the group 2. Okay, if it is from group 2, means that there will be sudden increase between IE2 and IE3. So recall back just now, which one show the sudden increase between IE2 and IE3? Yes, it's this one, element U. So your answer will be element U. Thank you for staying with me until here. So now we are ending the subtopic of ionization energy. So I will show you the short and simple final answer for tutorial chapter 3, question 5, question 6, and also question 7. So in the next video, we are going to discuss about electronegativity and also acid-base oxide character. Thank you.